everyone. Mr. Shields here to show you another way to determine which digits are significant. So if you remember from our previous lesson, we talked about determining significant figures and that the numbers 1 through 9 are always significant, meaning they always count. So the numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9 always count when I determine significant figures. They're always significant. So if you look at my example down here, the 7, the 8, and the 5, all three of these are numbers from 1 to 9, and so they're all significant. So I have 1, 2, 3 significant figures here. Now, zeros between significant digits are also always going to be significant, always. So if you look at the example here, I have 80,003. There are 3 zeros, but they're located in between the 8 and the 3. And the 8 and the 3 count as significant figures, obviously, because they're numbers 1 through 9. And so the 3 zeros in between are always going to be significant. So I have 1, 2, 3, 4, 5 significant figures here. Now, zeros in the front of a number are never significant. If you look at my example here, this 0 in the front will never count. So I have 1, 2 significant figures in this example because that 0 does not count. And if you look at trailing zeros can get a little tricky because sometimes they count and sometimes they don't. You have to look for the decimal point because trailing zeros are significant only if the number contains a decimal point. So if you look here at my bottom example, 500, there is a decimal point present. So the number 500 with the decimal point has 3 significant figures. But if you look here at this bottom one, there is no decimal point in this 500. So this one only has 1 significant figure. Now, today's lesson is about the Pacific Atlantic method. It's another way that you can use to determine the number of significant figures in a problem. So if you look at a map of the United States of America and you look at New York and Long Island is somewhere over here, you'll notice that we're on the East Coast and we swim in the Atlantic Ocean. And so I take that A from Atlantic and I use it to remember another word that starts with A, absent. And now I come over here, I hold that thought, I go over to the West Coast, I'm looking at California, and so I have the word Pacific because this is the Pacific Ocean, and the word I'm thinking about that starts with P as well is present. And the words present and absent correlate to a decimal point. So if a decimal point is present, I'm going to start counting from the left side, or should I say the Pacific side of the number. And if the decimal point is absent, I'm going to count from the right side, the Atlantic side. And so the rule is simple. I can start counting when I get to a number that's not 0, and I can count every number after that, including 0. But I can't ever start counting with a 0. So if you look here, I look at this number, and the first thing that I do using the Atlantic Pacific method is I look for a decimal point. There is a decimal point present, so I'm going to count from the present Pacific side. I can begin counting when I get to any number that's not 0. So I have 1, and it's a 5, so I can begin counting 1, 2, 3, 4, 5, 6. There are 6 significant figures here. Now, if I go to this other example, you'll notice that there is no decimal point present. And if there is no decimal point present, then I count from the absent Atlantic side. I can't start counting them when I get to a 0. So this first 0 does not count. This second 0 does not count. And I have 1 significant figure here. Let's do a couple of examples and then we'll talk about the rest of them in class. If you look at this first one, 6,007, right? Well, 6,007 has these zeros in the middle. And we know that zeros in the middle always count. So this has 1, 2, 3, 4 significant figures. If I look at my next example, I look for that decimal point. Is there a decimal point present? In fact, there is not a decimal point present, so I know that I have to count from the absent Atlantic side. Does not count, does not count, does not count, does not count, one significant figure. And I just realized that I didn't use the absent Atlantic way of solving it here. So let's go back to this problem and solve it that way. There is no decimal point present. That means I have to start counting from the right. This is a 7, so I can start counting, and I can count any number after that, including zeros. So I have 1, 2, 3, 4 significant figures, just like I did with the old way with zeros in the middle of 2 significant digits. The absent Atlantic method showed me 4 as well. Let's take a look here. There's a decimal point present, so I count from the Pacific side. I can't start counting here on a 0, but I can begin counting now that I'm at the 8. There are 1, 2, 3 significant figures here because that trailing 0 there counts, or in this way, the Pacific method, as soon as I saw a number that wasn't 0 like this 8, I could count anything after it. Let's take a look here. Also has a decimal point present here in this number 624, so I count from the present Pacific side. I can begin counting on any number that's not 0, and then I can count zeros after that. So 1, 2, 3, 4 significant figures here. And finally, our last one. Is there a decimal point present? No, there's not. So I have to count from the absent Atlantic side. I can't begin counting on a 0, so this 0 does not count. I have one significant figure here. Let me know if you have any questions, and we'll talk about this further in class